No additional interest. Receive $723 per month.
Linear.
You're not supposed to wait. Let people have a chance.
I'm just reeling it up. Yes.
Or exponential, right? So write it down. Which do you think it is? Linear, exponential? Survey says. What do you think? Linear. Yes. Why is it linear?
Per month, there's no additional.
Not because there's no additional interest. Yes, you are receiving the same amount each time. So if you were to graph it, you have an amount, you get 723. The next month, you get that same amount. Next month, same amount. So it's going to be linear, okay? Same amount. It doesn't depend on anything else. Letter B, the value of a machine depreciates. What does depreciate mean? Goes down in value. So this machine goes down in value by 17% per year. Think about it. Write down your answer, what you think it is. L or E, or linear, exponential. And what do you think this one is? Linear or exponential? Exponential. Not just because it's, well, sort of. Actually, exponential. I can spell. But it's 17% per year. So the first year it goes down and you have a new amount. And then from that amount, it decreases by 17% of the new amount. And then you have another low, and then 17% of that new low. So it keeps going down, down, down. Okay, so the percent, you're taking a percent of something, right? And that something is decreasing, whereas here it is every time 723. 723 stands on its own. All right, letter C. Every week, 9/10 of a radioactive substance remains from the beginning of the week. So write down what you think first, linear or exponential. Every week, 9/10 of a radioactive substance remains. That is exponential, yes. Because it's not the same 9/10 that we start with. Okay, it's 9/10, and then you get a lower amount, and then you take 9/10 of that, and that's what's left. Okay, so the amount that stays is different each time. A liter of water evaporates from a swimming pool each day. That is linear. Yes. Good. Because that liter, it doesn't matter if it's day 1 or day 438, it's still a liter. Nothing is changing that liter that's being evaporated every day. And the last one, every 124 minutes, half of a medicine dosage remains in your body.
Linear.
One of you is correct. I needed a tiebreaker. Is that linear or is that exponential? What do you think, Sajan? I think that is incorrect. Now, because it says half, think about it. If you start with a full amount and then you take half of it, then you only have half left. Then you're taking half of that half, which is a fourth. You take up a half of a fourth. So this half is half of something. When you take half of, that means you're multiplying. Okay, so yes, this is exponential. So listen again. Linear, $723 per month. A liter of water. Those are very definite amounts every single time. When we talk about 17% of something, okay, you're taking away 17%, then you have less. Then you take 17% of that smaller amount, and it keeps smaller and smaller. 9/10 of something. So you are taking a fractional part of something and you only have part of that the next time. Half of, those cannot stand on their own, okay? So that's why they are exponential. Any questions on A through E?
A through E.
Okay, turn now to page 100.
Yay. Probably not yet. Is it growth, decay?
Growth, decay, initial quantity, growth rate, growth factor, and a sketch. Now, I'm going to go to the end first. I'm going to go to the end first because I think you would want to maybe write some of this down, okay?
Where do we write it?
Probably at the upper margin, maybe in the top margin of that paper. So we know, so we know that the exponential equation looks like this, okay? A equals capital P times parenthesis 1 plus or minus R end parenthesis raised to the T power.
I think I might got it wrong because I did P plus minus.
Okay. Yeah, rewrite it like this. There's probably a formal name for the capital A. I don't know what it is. I just say, is it amount?
Yeah. That's
okay.
Like, how much you have in total.
Okay, well that makes sense.
Because like if you have the amount in total and then equation, right?
Okay. P stands for principal. Now this is not the principal as in principal your pal, but the principal as the initial amount. Initial amount. Mm-hmm. So here, that initial amount is always going to be a coefficient. Ooh, there's a math term we haven't heard of for a while. It's the coefficient in front of your base. Okay? So this is the initial amount right here, that P. All right, up next, let's talk about the growth factor. The growth factor is what is in parentheses. If you have the parentheses, the growth factor is everything that gets multiplied. Okay, it is often in parentheses, like so. And what do I want to say? What else do I want to say? Ah, yes, it is also the base of your power to the exponent.
For P, what does that say? You said initial something.
Initial amount, AMT. So the growth factor, often found in parentheses, it is the base of the power of your exponent. That whole thing is the growth factor because the factor, the T tells you how many times you are multiplying it as a factor. Okay? Next up, let's talk about R. This is the growth rate. Well, we're not always talking about money, though. This is the growth rate.
Is it interest rate? Same thing for like money.
IRT. P equals IRT. No. So the growth rate is the amount that is added or subtracted from 1. So if you have something like 1.78 as your growth factor, then the rate is 0.78. Okay, let's say one example, e.g., that's Latin, for example. If I have 1.78, then 0.78 is the growth rate. I know, you're like, there's not this much room up here. Or you can also say as 78%. You can do it as a percent or as a decimal. If I had something like, let's do 0.78, that means your growth rate is negative 0.22. It's a negative, okay, which would be a negative 22% because this is below 1 and the rate is negative 0.22. Okay? And finally, we have T, which is your time in years. T is time in years. Now, I think all of these things are kind of important because they just like say, hey, here are these problems. But maybe this helps you a little bit in identifying these different things, okay? Now, let's go back to problem number 1. So, first of all, I don't love the order that they start with these, so I'm going to make up my own order. So, let's talk about first the initial amount. The initial amount. As you look at this, okay, what is the initial amount or the amount that you start with?
8.
8. Yes. Remember, it is the coefficient. It is your coefficient in front of what is in parentheses. Next up, I want us to look at the growth factor. What is it that gets multiplied over and over?
1 plus 22%.
Well, here
Wait, x plus
it is,
1.
let me erase this, 1.23. So if this t were a 2, it would be 1.23 times 1.23, and it would be multiplied twice. If it's an 18, 1.23, that's the factor that would get multiplied times itself 18 times. Okay? Number 3, let's talk about the growth rate. Can you see over this, or is this right in the way? Okay. The growth rate. Now, this is the amount that is above or below 1. It is above. So if you subtract 1.23 minus 1, you get as a decimal 0.23 or 23%. So you can do it as a decimal or as a percent. And then finally, is this showing then growth or decay? Growth. Because it is growth rate of over 1. Or I could say the factor is greater than 1. All right, the last thing it talks about, which I think you might have room to put in the far right-hand side on your paper, I'm probably going to have to do it below each one, is to do a rough sketch. A rough sketch. Now, please ensure that you have some sort of a calculator near you, okay? We're going to do a sketch. So, here is our equation, okay? When I substitute 0 in for t, that would be the equation P substituting 0 in for t. So if on your calculators you put and find where t is equal to 0. That's 8 times 1.23. On the yellow calculators, I believe all you can do is the caret to 0. Anything to the 0 power is, do you remember? No. 1. So 8 times 1 is going to give you 8. But I would love for you to actually put this in on your calculators. So you would say 8 parenthesis 1.23 caret 0, and you should get 8. I thought there was like a bug on the table or something.
No.
All right.
I forgot to grab out my calculator.
Gotcha.
Wait, so
let's do this one by like 5, 10, 15, 20. 5, 10, 15, 20. Yes. If you substitute 1 in for t, that is, think about it, that's just 1.23 to the first power. So 8 times 1.23, you will get 9.84. I have already done these. So I just want to make sure you understand what is being done.
what happened? Where'd you get 9.84?
9.84.
Yeah, where did you get that from?
I substituted 1 in for t and then put it in my calculator. 8 times 1.23 raised to the first power. Okay? When t is 2, that is 12.1. 12.1,
yeah.
And when t is 3, it's 14.88.
Oh.
That's fine. So let's do a quick graph here. 1, 2, 3. Not going very far. So on the y-axis where time is 0, that is 8. That's where my graph is starting. That's your initial amount. Where time is 1, that's 9.84. That's very close to 10. Time is 2, that is 12.1. And where time is 3, 14.88, that is very close to 15. Now, that is not many values to show you, but it is definitely not linear, and it looks like it would be going upward like this. And you could put in 10 and 20 and all kinds of other values, and it will continue to go up. Questions on that? Rough sketch, very small rough sketch. All right, let's take a look at problem number 2. Problem number 2. What is the initial amount? Somebody else. Let everybody else try. I know. What's the initial amount? Anybody? Che, are you with me? What's my initial amount in this exponential equation?
3.1.
Yeah, 3.1. It's the coefficient out in front. So 3.1. All right. Why did I put a 2 there? I don't know. 2, the growth factor. Growth factor. Damari, what's my growth factor? What gets multiplied over and over? Look at it. This right here. I can't hear you. That is correct. It is the base that you have, 0.78.
What if you just put 0.78?
That's fine. So number 3 is the growth rate. Now you got to look at this because it's either 1 minus something or 1 plus something. Well, this definitely is less. So if you take 1 minus 0.78, you get 0.22, negative 0.22, because it was 1 minus that amount. So it's negative 0.22 or negative 22%. Does that make sense?
Well, I don't get it. Why did you keep the negative side?
We're just showing that it is a negative amount. We can't put positive, it's not 1.22, right? So we have to show it was subtracted. And then 4, is this showing growth or decay? If your growth factor is less than 1, then that is definitely showing decay. It is getting smaller each time. So if we do a little graph, let's do this. Let's go up to 3, 1, 2, 3, kind of spread them out a little bit. And let's just do 3 on the bottom, 1, 2, 3. So your initial amount is always what it is when t is equal to 0. If t is equal to 0, anything to the 0 power is 1, and 3.1 times 1 is 3.1. So that initial amount is always kind of your y-intercept. We know it's decaying, so it's going to go down. So let's see. Q when t is 0 is 3.1. Q when t is 1, I will tell you, is 2.4. When Q is 1, 2.4. So just under 2.5. The equation when t is 2 is 1.88, which is just a little bit under 2. And when Q is 3, 1.47. Boy, this is rough. Okay? So again, exponential, it's not going down by the same amount. It's going to make a curve and get closer and closer to 0. Any questions on that? All right. Can I move to the next one?
No.
No.
Not yet.
The next one is a little more involved. But look back at the top, what you have in that top margin. So first of all, what is my initial amount? That is not correct.
0.
No.
1.
Any other guesses? Are you guessing?
Yes.
All right. Think about it this way. This is your base to the exponent, correct? So this really must be the growth factor. The growth factor is the base of your exponent. That is 3, so the initial amount would be the amount in front, the coefficient, which is actually going to be 1. So the initial amount is 1. That is your coefficient. Growth factor is the base, which is 3. If I am doing my growth rate, it's either 1 plus or 1 minus. And if you think about that, it's got to be 1 plus how much? What does this have to be to get 3? What does that have to be? 2. So that means this is 2.00 or 200% as the rate. That is a full 200%. And that is definitely a growth, showing growth. You're increasing by 200%. Now, notice our time here. We took time and we divided it by 2. What is that going to do in general? If I had t versus t divided by 2, what is that dividing by 2 going to do? Yeah, it's half. So it's going to slow it down. So t, let's say this was like 8. Ugh. Say t was 8, and here we had 8 divided by 2, which is 4. So this t divided by 2 is going to slow down your time, not make it go up quite as quickly as if it were just t. So let's do a sketch. We'll do 1, 2, 3, 4, 5. 1, 2, 3. I think next time we should give you guys the sketches in here, at least the coordinate planes, right? So y of 0, your initial amount is going to be 1. Y of 1, when time is 1, that's 1 over 2. 3 to the 1/2 power is going to be 1.73. 1.73. Y to the 2nd power, well, think about it. If your time is 2, 2 over 2 is 1. 3 to the 1st power is 3. And y to the 3rd, not y to the 3rd, y with a time of 3 is 5.19. 5.19. So this is going up pretty quickly. Okay? Because you have a 200% rate. It's kind of being slowed down because your time is divided by 2, but it's still going up rather quickly. All right. Number 4, letter D in your book. What is the initial amount?
1.
That is correct, because this is your base again.
Coefficient is always 1.
Coefficient.
Always
Not always.
No, I mean like when there's
It is
no
here.
number.
Yeah, if there's no number in front. Yes. Growth factor. What is your growth factor that gets multiplied over and over here? What is my growth factor? 3/2. Good. Okay, that is your base. What is my growth rate? That is either the part that is above 1 or the amount that we subtracted from 1. What's another name for 3/2 as a decimal? 1.5, right? 1.5. Why is this not writing? So that growth rate is 0.5 or 50%. And the last one, it is a growth. Okay. If I were to do a graph with this, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 over here. We'll just get 1, 2, 3. Your initial amount is 1. Okay. So W when t is 0 is 1. The equation when t is 1 is 1.5, 1.5. So that's right in between 1 and 2. The equation W when t is 2 is 2.25. 2.25. And the equation when time is 3 is 3.375. 3.375. So again, an increase. All right, we got one more. One more. Are you ready? Last one. So the equation P equals 10 times 3 to the t divided by 2. What is my initial amount? Osmond, what's my initial amount for this equation? 10. Yes, that is your coefficient. Okay. Next up, let's do the growth factor. Eli, can you tell me what the growth factor is? It's your base of the exponent. 3. Very good. That's your factor because it gets multiplied over and over and over. Faith, can you give me the growth rate? It's whatever is above 1 or whatever is subtracted from 1 in my growth factor. No. It's going to be whatever is 1 plus or minus right here. So since my growth factor is 3, what does R have to be? No. I need 1 plus something gives me 3. So that's going to be, so it's going to be 2. 1 plus 2 gives me 3. So that great growth rate is 2 or 200% as a decimal, because that would be 2 point. And the last one. This is definitely showing growth. If I do a quick little sketch of a graph, this one probably should go by 5s. 5, 10, 15, 20, 25, and 1, 2, and 3. My initial amount, we just said, was 10. So when P or T is 0, you're going to get 10. When T is 1, you're going to get 17.32. This goes up very quickly. When T is 2, you get 30. When T is 2, you get 30. Oh, that was horrible. So it is going up very quickly, even despite the fact that your time is cut in half. It's because your growth factor is so large. Okay? All right. So I am recording this. You can go back to it and watch or copy down if you need to. The last thing I want to tell you, oh yeah, forgot I did that on that page, is that your homework topic 7, homework 1, would like that to be done by Monday midnight. Now, if you don't get it done by then, no sweat, because it won't officially be due until the day that we have the project due. But ideally, if you can get that done by Monday. Okay? All right. That's all I've got. So how many are going out for prom tomorrow? All right, nice. Who's definitely staying home? I thought you raised your hand for going out for prom. Your what? Staying home. Oh, Monday. I meant just staying home on prom night. Gotcha. Staying home Monday. What's Monday? No, I know. It'll be interesting. Anything else? Good, bad? It's supposed to be a really nice day today. But like I said, Saturday and Sunday, kind of cold and rainy. So make sure you have an umbrella. Maybe. Umbrella? Maybe. The outfit doesn't need an umbrella? Really? It's going to ruin it? Oh.